can Claude help us figure out legacy code, and can AI assistants help us with that? We'll see about this today. This is the first session from what I promised that I will try, and that is a series of exercises in which I try to use Claude or other AI assistants for realistic code problems, software development problems. And the first one that I thought about starting with is legacy code. It's true on a very small scale. So let's see how this goes. But first, welcome back to Think Design Work Smart. I'm Alex Bolboaca, and I'm coming at you from an undisclosed location, not my usual Mozaic Works studios. And today we will look at using AI assistants for understanding legacy code. First of all, let me show you the code we are dealing with. This is an implementation of the Snakes and Ladders game, but it's an implementation that we use for clean code refactoring and for legacy code. And what as you can see, it's not a very long code file. This is about 260 lines. There are a few other files, but this is the most important one. And I'm just gonna scroll through it. It's basically a very naive implementation of Snakes and Ladders. With a lot of inconsistencies, with a lot of weird stuff, with a lot of limitations that shouldn't be there, basically. So now let's Claude had to say about this. This is my conversation with Claude. I started by saying act as a specialist in legacy code. Usually it's good to ask for a specialization, for an expertise. Now, I'm not sure there is such a thing as a specialist in legacy code, but typically it's useful because it will help the AI assistant pick certain paths through its model. And initially I wanted to ask him about another code base, which is trivia, but he already knew that code base, so I'm gonna skip this. Then we had some problems accessing the code on GitHub. Finally, we managed to fix it. And first of all, it says, okay, now I can see the repository exists, an ugly implementation of the Snakes and Ladders game with tests to use for refactoring and clean code practices. This sounds perfect for legacy code analysis. Let me try to get the code. We focus on the file, finally figure out I had to give him the raw file. I think you can also integrate with with GitHub, but I didn't do that. I don't really want to do that. Okay, so I showed it, and then first response, excellent. Now I can see the code. This is indeed a fascinating example of legacy code with numerous issues. Let me provide a comprehensive analysis. Approach to understanding the problem. When I encounter unfamiliar legacy code like this, I start by understanding what it's supposed to do, then identify the patterns of problems. This appears to be a Snakes and Ladder game implementation, but it's immediately clear there are serious design and implementation issues. And it figures out a few issues, that there's a constant call max that is 1 and a constant call min that is 34. Says this is backwards, max should be larger than min. Cryptic variable names, BP, I'm lucky, in a single word. D1, with a number, a digit 1, and D2 as a string. Massive code duplication. The play method contains the exact same switch statement twice, once for the human player and again hard-coded for computer player 2. This violates the right principle catastrophically. I kind of like this. That is a real problem indeed. Singleton anti-pattern, so we are using a singleton just for fun. Mixed responsibilities. The game class handles game state management, console out, game logic, player management, board configuration. Yeah, it does everything. That's the point. Except I think for dice and inconsistent board setup. The constructor has bizarre logic mixing board setup with validation checks that don't make sense. Dead code and logic errors. It found an else if I greater than mean and I less or equal than mean. This condition can never be true. That is correct. Hard-coded game flow. Player 2 is hard-coded as the computer player, making the game inflexible for a different number of players. Understanding the game logic. So now this is what it understood. Despite the messy implementation, I can deduce board squares 1 to 36, though logic suggests it should go to 100. Ladder squares, 2 jumps to 15, 5 jumps to 7, 9 to 27, 18 to 29, 25 to 35. Snake squares, okay. Win condition, reach square 36, two-player, human and computer. And now it jumps directly into the refactoring strategy, which, to be fair, is the typical legacy code strategy. So it's the Michael Feathers method, add characterization test, then start extracting things, cleaning up, and so on. Now, what I wanted to do is to do a little bit more than that. And one thing that I don't like about Claude is that it jumps directly into giving a lot of details. I don't really want that. What I want is to see that, to first have a conversation so that we understand better what's going on. So then I asked, can you explain the implementation? Well, we have a game initialization with singleton creation, and actually picks up the code that does each of these things, which is great. Board setup constructor logic shows that. The constructor sets up a bit dictionary with maps special squares to their destinations, MP array tracks positions of 4 players or start at square 1. The special squares configuration, despite the confusing conditional logic, the board essentially gets these mappings, so that is correct. Now I didn't check the actual mappings. Maybe it might have missed some details, right? The confusing validation logic, okay, is valid mean greater than max. This is backwards, yeah, on purpose. Gameplay flow, when you call play of string player, here's what happens: human player turns. Movement and special square checks, generate result messages. And then here's the bizarre duplication. Here's where it gets really strange. The exact same logic runs again for player 2, the computer. I equal 2, dice roll, d1 plus d2, and so on. So every call to play actually moves the requested human player, immediately moves the computer player, always player 2, returns a combined message about both moves. This shows all 4 player positions, even though the game logic only seems to use player 0 to 3, and only player 2 is the active computer opponent. What this implementation actually does, it's a 2-player game, human versus computer disguised as a 4-player system. Every turn processes both players. Board is 36 squares. Special squares are hard-coded. Game state is global, console output is mixed. And then why this is problematic: unpredictable flow, calling play of 0 also moves player 2, no turn management, can't implement proper alternating gameplay, hard-coded opponent, code duplication, and pore separation. Now, I'm curious to ask him one thing, so let me try this. How do you know that the second player is a computer player? Now, what's interesting is that it got this kind of right, but it's also not really right, okay? Because this doesn't actually implement human player. There is no human player here. The only reason why it says it's a human player is because there's a string for human player. Okay, so let's see what he says. Re-examining the computer player assumption. You're absolutely right to question this. By the way, it always answers with you're absolutely right to. This is one thing that I don't really like. I mean, you should tell me that I'm wrong occasionally. I made an assumption that isn't actually supported by code, what the code actually shows. My incorrect inference. I saw the string computer in the outbound messages and assumed player 2 was meant to be a computer opponent, but this was my interpretation, what the code definitely proves. What we actually know. Player 2 is always moved after the requested player. Different output messages are generated for player 2 mentioning computer. Hard-coded behavior. Okay. Alternative explanation, the computer references could be placeholder text from incomplete implementation, copy-paste artifacts, debugging remnants, actual computer player implementation. So it fixated on computer player. So now there are different levels of analysis for this type of code. This is what makes it tricky, because you can analyze this based on what's in the code and trust the messages, but you can also analyze it based solely on what the code is doing. And based on what the code is doing, there is actually no human player. Everything is controlled. Anyway, that's one example. And my feeling is that if I start to ask some more questions, Claude will start to get cornered really quickly. But I'm not going to do that right now. Okay. So what else? So can you explain the implementation? The next prompt. What would I need to minimally change in order to add a third player? These I like these kinds of questions that ask for changes. So one reason for going into legacy code is to fix bugs, and the second one is to implement a new feature, to make a change. And if there is no with legacy code, it's difficult to change the code. And so it's interesting to see, does it understand what is needed to change? Minimal changes to add a third player. Looking at the current implementation, here's the minimum required changes to add a third player. Current problem, the play method is hard-coded to move exactly 2 players, the requested player and player 2. Minimal solution approach. Option 1, extend the hard-coded pattern. Yeah. This is problematic, triple code duplication, no turn control, growing method size, maintenance nightmare. Yeah, that's pretty much correct. Slightly better minimal change, extract the duplicated logic into a helper method. But the fundamental issue is, the real problem is architectural. The play method is designed around the assumption that every call processes multiple players. To truly support 3 players properly, you need to rethink the game flow entirely. Yeah, that is correct. So I think it figured out the right approach. The 2 approaches that you normally see. Now, there is another approach, which is to refactor everything, but I asked for the minimal changes. So that is pretty good. Then something really interesting happened. I asked Claude, does this code have any bugs? And what is the first bug he found? Inverted logic bug, critical, return mean greater than max. This is not a bug. It's a clarity problem, but it's not a bug. The code works correctly with this because mean and max are actually reverted. Mean is 34 and max is 1. And is valid actually doesn't do anything, the method that contains mean greater than max. So that will always return true. But he says, okay, it's a bug. Second, dead code bug. Again, problem, code problem, not a bug. 3, inconsistent return logic bug. Another one that is not a bug. It's a problem with the code. Array bounce potential bug. If someone passes a string that converts to a number outside 0 to 3, this will cause an index out of range exception. That is correct. So, but is that really, I mean, it says it's a potential bug, so I will let it pass. Win condition inconsistency bug. Different win conditions for human versus computer players. Human must land exactly on 36. Computer just needs to reach or exceed 36. Impact unfair gameplay. Computer has easier win condition. That is correct. So it found a bug. Game state corruption bug. That is not correct. This is absolutely not a bug. The code works with that. Just overrides a variable because it's I1, I2. Now, it's very confusing. It's a very bad code, yes. But the code, the functionality still would work with that. At least with 2 players, which we know is the limitation. Potential infinite game bug, because, but this is a duplicate to the other one. So basically, human players, if they pass the last field, they can just continue playing. Dictionary key collision potential. While not currently triggering due to the specific conditionals, the structure could lead to attempting to add the same key twice to the dictionary. Conditions overlap. Yeah, but conditions don't overlap. So again, this is a potential code issue, not a bug. Resource management bug, minor, the singleton pattern with no cleanup. Actually not, this is C#, it will get cleaned up when the program closes. Inconsistent player indexing, again, not a problem. So it didn't understand bugs. It found one, which is correct, and another one which is the duplicate of the same one, but it didn't actually find bugs, which is interesting. So why would it not find bugs, but it would find it would understand the code? Well, I know it doesn't actually understand the code, right? For everything there is a prompt. So every one of these operations is roughly independent. There's no there's no unifying context, or not as strict as we would believe it to be. Let's say like this. Okay, then I asked, what would you propose as a resulting design after refactoring? And it started to create a lot of code. This is another thing that I hate. And I actually have in the instructions, don't generate code, but I guess I would have to change my settings to be clearer. Don't generate code unless I ask you to. I want to have a discussion first. But anyway, please refrain from generating code unless I ask for it. Okay. And it says propose design after refactoring. High-level architecture approach, layered architecture that separates concerns, domain layer and application layer and presentation layer. Not that great. Okay, so the proposed solution, I mean, it's kind of correct, but it's about 3 classes. It's not, or well, 5 classes. It's not that complex. It sounds very enterprising. Key design principles, single responsibility, dependency injection, and so on. This is just BS because it's what anybody would say. Core entities ID extract. This is where it gets interesting. Player, encapsulate player state, position name with status. Board, manage the snake ladder configuration and position calculations. Move turn results. Should we? I'm not that sure. And game coordinator. Now this is one class that I hate because coordinator is just a generic name. It's slightly better than manager or these generic names, but it's not great. I don't think that's needed. Addressing current problems, turn management, and so on. Okay, give me, and then I said, let's think this in a different manner. I want to create a refactoring plan formed by small refactorings with specific goals so that we can work incrementally and verify the results at each point. Can you create a refactoring plan that fits these parameters? All right. And so first, add characterization tests. Good. Step 2, fix critical bugs. Okay. This already is kind of not the point. Sometimes you need to do that. Sometimes you need to double check that those are actually bugs or that they have not become features in the meantime and people are counting on them. Maybe the code started with 4 players, but what if we have a customer that's using this code and is counting on it working just with 2 players? No. Fix constants and dead code. I think that is correct. So renames and removing, basically a cleanup. Then extract and clarify. It says extract dice rolling logic. Yeah, because we are rolling 2 dice. We can extract that. That works. Extract constants for magic numbers. Yeah. Maybe. Extract move calculation logic. Yeah. I mean, I'm not that sure. Well, I don't like the name. Calculate new position, current position, dice roll. Not that great, but we're kind of moving in the right direction. Extract result message generation. Formatting. Yeah, that's a good one. Eliminate duplication. Extract player turn processing. Process player turn. I don't like the input parameters here, but there's player index and player type. Not sure that's the right thing. Introduce player structure. Fixed win condition consistency. Yeah. Well, careful because maybe it's something that other people are counting on, so only after you double check. Improve game flow, introduce turn management, remove singleton pattern, make player count configurable. And finally, clean architecture, separate game logic from I/O. Honestly, this is something that we could do from the very beginning. Can be part of the cleanup. It's actually gonna be part of, well, it's easier to write characterization tests if you don't have console. Input output in the code, so probably you'd get rid of that before, but yeah. Verification strategy, key steps, board representation. Okay, And then I asked, how would you represent the board? And it proposes a dictionary with special squares, dictionary of letters, option 2, dictionary of value objects, option 3, letters and snakes. I prefer this one, although it can be more like source to destination, because letters go in one direction, snakes go the other direction. But honestly, I would feel better if I had a data structure that does the connection between two fields and then two data structures, one snakes, one letters, because I feel that's closer to the domain model. The game is called Snakes and Letters. I like to see snakes and letters in the code. Okay. And then I asked him, let's go back to the list of bugs. You included the code clarity issues that max and min are reserved. That is not a bug. Can you review the list of bugs and double check they are correct? Let's see what he did. Actually, not bugs, max min naming. Is game playable logic not a bug? Confirmed actual bugs. Array bounce bug? Yeah, could be. Not that risky, but could be. Win condition inconsistency, real bug? True. That code bug, real bug. That is not a bug. So it still doesn't know what the bug is. Now I wonder if I would ask him, if I would ask it instead of act as an expert in legacy system, act as an expert in, in code or something like this. Can you actually figure out what the code does? And then you saw me asking, how do you know that the second player is a computer player? And it figured out that maybe it's not. It's an assumption. So this was the whole analysis, the whole session with Claude. Overall, there are some good things and some bad things. On the good side, it figured out what the code is doing, which I guess was fairly easy based on the name. But it figured out some details and some weird things from the code. It pointed out to coding problems, but it could not figure out, and it was able to give me a plan for introducing a new player, so for adding a new feature. On the other hand, it could not figure out bugs, even after the second iteration. So something didn't quite work there. But it pointed me to some places where I can look, which is good. I don't expect it to work independently. I expect it to at least help me a little bit. And it gave me a refactoring plan, which is not really great. I mean, it's kind of mediocre. It has a good start, but after the start, it kind of gets lost. So, hit and miss. As you can see, the larger the context, the more errors you'll get. So what I would do instead, if I were to use Claude for legacy systems, I would say, okay, what would be the first step in our refactoring plan? This is the one, apply that. Then look again at the code, what is the next step, and so on. And in that way, I think it would give better results. Let's also clarify and be very clear on the fact that this was a very small problem and it was easy to grasp. However, it did help. Right? I know from experience that people are struggling with this kind of problem, and it already gave a lot of good information for people who would be trying to deal with this. I know it because I wrote it. It's true, I don't remember it that well, but it's still something that I wrote. So that's it. What's the final conclusion? You can use AI code assistants, but as I usually say, use them on specific problems and small contexts. This is where they can actually help. What do you think about all this? And do you have any ideas for another session with Claude? Let me know in the comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.